Hello students, welcome. Previously, lesson 7 from 2 to week 3, we were dealing with the second type of structure of covalent bonding, which was giant covalent or giant atomic structure. So today, lesson 8, we want to proceed to the third type of bonding, which is metallic bonding or metallic bond. And we're saying this is a type of bond where there are many atoms surrounding in one atom, and therefore the valence electrons are mutually attracted to many nuclei. We are saying metallic bond occurs in metals. Remember, when we were dealing with the ionic bonding, we said ionic bond exists when a metal and non-metal react, like when sodium reacts with chlorine. Sodium is a metal while chlorine is non-metal. So the type of bond that will exist in between them will be ionic bonding. We said covalent bond exists between non-metals. For example, when sulfur reacts with oxygen to form sulfur peroxide is having a covalent bonding because sulfur is non-metal while oxygen is non-metal. So we are saying here metallic bond occurs in metals or exists in metals. So let's go next to the structure of metallic bonding. The structure of metallic bonding is called giant metallic structure. Remember, when we were dealing with ionic bonding, we said we are having giant ionic structure. When we are dealing with covalent bonding, we said we have two structures. One of them was molecular structure, and the other one was giant covalent or giant atomic structure. So when we are dealing with metallic bonding, we are having giant metallic structure. So we are saying in this bond, there are many atoms surrounding any one atom, and therefore the valence electrons are mutually attracted to many nuclei. Then we are saying the electrostatic forces of attraction between the positively charged nuclei and the negatively charged delocalized electron holds the atoms together in the metallic structure. Remember, we said atom is made up of three subatomic particles. One of them is positively charged protons, and the other one is neutrons, which are neutral, and we said it's having electrons, which are negatively charged particles. So we are saying the electrostatic force of attraction, that's the metallic bond between the positively charged nuclei, that's the proton, and the negatively charged delocalized electrons. Those are electrons are the ones holding an atom together in a metallic structure. We are saying the mutual electrostatic forces constitutes metallic bonds, which are strong bonds. So we're saying metallic bonds are strong bonds. So what we have here is the structure of metallic bonding. Check here very well. So we're having immobile positive metal ions. So these positive ones that we have here is the positive metal ions, and what we are having here are the delocalized electrons or mobile delocalized electrons from the outermost energy level. If you check here, we're having +2, that's the charge. It's written here, charged nucleus. So +2, that means when I'm dealing with something like this with only one, it's just from group 1 elements or from alkyl metals. So when you have +2 in the nucleus, that means we are dealing with the alkaline earth metal or group 2 elements, because charge of +2 means that the atom has lost 2 electrons from its outermost energy level to form a charge of +2. That's what it means. Remember, we said when you give it a plus, that means it is like loss of electrons. When you give it negative, that means it's like gain of electrons. So next, let's go to the physical properties of metals. We are going to use this table to see the physical properties of metals. Here we have the electrical conductivities. Here we're having good. That means metals are good conductors of heat and electricity. If you check here, the melting point and the boiling points of metals are relatively high. So we're saying metals are good conductors of heat and electricity, and the reason is we're saying this due to the presence of the localized electrons in their metallic structure. Remember, we say the localized electrons are the ones that are responsible for the electrical conductivity. The next point we are saying the electrical and thermal conductivity increases with increase in the number of delocalized electrons. That means the higher the number of delocalized electrons that an atom or an element or a metal has, That means the higher the electrical conductivity. Therefore, we are saying aluminum has a higher electrical conductivity than magnesium and sodium. Remember, aluminum is having an atomic number of 13 with electronic configuration of 283. So when we talk about magnesium, magnesium is number 12 and it's having an electronic configuration of 282. Then sodium is number 11 with electronic configuration of 281. So if we check the number of the localized electron, that means sodium is having one delocalized electron, magnesium is having two delocalized electrons, and aluminum is having three delocalized electrons. Then that means aluminum will be having higher electrical conductivity because it has more delocalized electrons than magnesium and also sodium. So next we are saying metals have relatively high melting point and boiling points. This is because they have giant metallic structure with strong metallic bonds that requires a lot of heat energy to break. Remember we said metallic bonds are strong bonds, then for them to be broken down it requires a lot of energy. So next we are saying typical metals have a silvery surface, but remember this may be easily tarnished by corrosion or oxidation of oxygen or oxidation in air and also water. Then lastly we are saying unlike ionic solids, metals are very malleable. That means they can be readily bent, braced, or they can be hammered into shapes. So next, let's see this example. We are told the diagram below represents the structure of element N, and we are told in bracket, not the actual symbol. So that means you have to know that N is not the chemical symbol of the element that has this structure. So check very well. We're having the positive nucleus of +2, then these are the delocalized electrons or mobile electrons. So the first question we're asked is that name the type of structure. We have not been told name the type of bonding. If they could have asked us the type of bonding, we could have said metallic bonding. Then they have asked us name the type of structure. This type of structure is known as giant metallic structure. In part B, we are told in what group of the periodic table does element N belongs. We are told give a reason. So here we are told in what group, but during the exam you can be told in what family of the periodic table does element N belongs. So the way you see this element N or this structure has a charged electron of +2. So that means it has lost 2 electrons to obtain the charge +2. So that means the element is in group 2. In case you're asked about the family, you talk about the family of group 2, that is alkaline earth metal. So the reason why it is group 2 is that we are saying this because each atom has 2 valence electrons which it releases or loses into the sea of free electrons or mobile electrons. Learners, that is the end of our class today. Thank you for watching.